Hello to all of you, this is Dr. Dhaval Maheta and today we are going to discuss about normality testing of the data in R. Now what do I mean by normality testing and how to conduct it in R? Let's try to understand. First of all, we must be aware about the characteristics of the normal distribution curve. It is a continuous random variable, it's a bell-shaped curve, mean is equal to median is equal to mode. Both the x's are asymptote. It is unimodal. It's having one mode only. Symmetrical on both the sides. First quantile is equal to third quantile, and the total area under the normal curve is equal to 1. Now this is a definition. Now how does it look like? Let's see. So what does this talk about? It says that normally when you collect the data on the random variable that is distributed normally, say for example height, then what are the chances that there is a very tall person in your class? Very less chances. Say for example here, what are the chances that there is a very short person in your class? The chances are very less. More and more frequencies or more and more students will be towards the center of the data, and therefore when I compute, or rather when I plot this graph, I will get the normal distribution. Similarly is case with the weight. Similarly is case with the intelligence, right? Now if I talk about how much area this bell-shaped covers when we take the observations which are equal to mean plus or minus 1 standard deviation. So it covers 66.7% observation. It means that if you are having 100 students in your class and you take the mean height of the class and plus or minus 1 standard deviation is considered, then approximately 66 or to 67 students will be under this rule of plus or minus 1 standard deviation. If I take plus or minus 2 standard deviation, 95% students will follow this rule, 5 will be beyond this. If I talk about plus or minus 3 standard deviation from the mean, 99.7% will be there inside this curve. Now, why is it necessary to test the normality of the data? The reason is that we want to deploy parametric test or non-parametric test. The basic assumption in all the parametric test which we are going to use in our future videos, that is parametric test is like t-test and ANOVA. The basic assumption is that it requires that your variable is normally distributed. Now if we talk about some statistics which were used before some years, then the statistics were skewness and kurtosis. So ideally skewness should be 0 and the kurtosis should be 3. But now we are having some more types of graphical representation also, and as well as we are having some test also which will talk about the testing of normality. So tools for assessing the normality are, we go for histogram or box plot, and the advance is we go for normal quantile plot. These are all graphical representation. The test which we will include is Shapiro-Wilcoxon test, one of the most popular tests, and the another one is Anderson-Darling test. Now let us see how we can carry out this test in R. The null hypothesis of this test is that the distribution is normal and the alternative is distribution is not normal. Common test of normality includes Shapiro-Wilcoxon, Kolmogorov-Smirnov, Anderson-Darling and Lelafeu's test. Problem is that they don't always agree. But in such scenario, we should always go for Shapiro-Wilcoxon test. If the sample size is small, then you use Shapiro-Wilcoxon test. Now small is a very disputable term. There is no such clear-cut definition that what do I mean by small sample size. The central limit theorem specifies that the small is 30, but here we don't have definite literature to say that how much is a small sample size, right? And some academicians consider less than or equal to 2000 to be the small sample size. Okay, now how to carry out this normality testing in R? Let's go in R scripts. First of all, let us run the carbon dioxide data frame, which is the default data frame in R. Now there are variables like plant, type, treatment, concentration and uptake. Concentration is a continuous variable, you can see. Uptake is a continuous variable. Now we will run the command attach CO2 to make the command line simple. Once this is done, there are many methods to test the normality. So first of all, I can check I'll say plot the uptake, plot the histogram of uptake. And you can see. The second is I can also go for density plot, uptake, density plot possibly. Just a minute. Let me reorient myself. Zoom in. Right. First of all, I will have to activate the library ggplot2 run. Then I'll say plot into bracket density uptake. So it will give me the density function. Now these are the two techniques which were used previously. But now we are using QQ norm, quantile norm, uptake. Then we will run QQ line, which will superimpose this curve. Now what is the meaning of this? Let's try to understand. If your data is normally distributed, then all these points which are there, it should be on the straight line. But you can see there are some points at the fag ends. These are considered to be the outlines. We don't follow the normal distribution, and therefore we can say that the data is not following the normal distribution. But at present, we can interpret nothing from the graphical representation of the data. It's just we are able to say that there is some issue in the normality. But to establish that the normality is present or not, we will have to conduct the formal testing. We will run the library ggplot2 to get some good plots, quantile plot. Now the same plot I will get in much organized form with a grid line. I can also include the colors in this, or rather I want to say that I want to establish the normality according to the treatment which is given to the plant, chilled, non-chilled. I'll run it. There are two lines, or rather two curves are there, separated by chilled and non-chilled. I can establish the separate normality for both the factors. Similarly, I can run for the type of the plant also. Now, I want to carry out the formal testing of normality in the data. So for that, the null hypothesis is data follows a normal distribution. The alternative is data does not follow the normal distribution. The command line is shapiro.test uptake run. Here, the p-value is less than 0.05. We reject null. There is a thumb rule for testing for all the test. And the thumb rule is if the p-value is less than 0.05, we reject null hypothesis. If the p-value is more than 0.05, we fail to reject null hypothesis. To carry out the Anderson-Darling test, we will activate the library NOR-test. Run. Here also you get the p-value which is less than 0.05, and you can interpret that we are rejecting null hypothesis. The assumption of normality is violated, and therefore we are not in the position to carry out the parametric test. All these codes are available in my book, which is available on amazon.in. Just a minute. You can see my book, which is available on amazon.in as well as amazon.com. The name of the book is Data Analysis Using R by Dr. Dhaval Maheta. You can subscribe to my channel. You can follow me on the LinkedIn and Twitter. Thank you.